Hello guys, welcome back to the channel. Today we're going to solve this Leetcode question, which is minimum number of days to make M bouquets. So I'm going to explain you very easily. This question actually took so much amount of time just to understand how to solve this. So we're going to solve this question by using two approaches. One is a brute force approach. The second one is the optimizer approach. So initially, the brute force approach we can think of that, but by looking at the constraints, we know that it cannot be solved by using brute force approach. So and then we'll move to the optimizer approach, and we'll try to see why we are using that particular optimizer approach instead of using other techniques. So let's go through the question right now. So we are given an integer array bloom day, an integer m and an integer k. You want to make m bouquets. To make a bouquet, you need k adjacent flowers from the garden. So the garden consists of n flowers. The ith flower will bloom on the bloom day of I, and then can be used in exactly one bouquet. Return the minimum number of days you need to wait to be able to make M bouquets from the garden. If it is impossible to make M bouquets, return -1. So I know this question is a little tricky to understand, but I'll explain you very easily. So we're basically given an array which is called as bloom array, and we are given two variables which is m and k. Here m is nothing but number of bouquets we need, and k is nothing but number of flowers in each bouquet. And the array consists of, each element represents the the day on which the flower will bloom. Basically, the first flower will bloom on day 1, and the second flower will bloom on day 10. This flower will bloom on day 3, this flower will bloom on day 10, and this on day 2, like this. So, what we need to do is we need to pick k adjacent flowers from the garden. K is nothing but k is given here, right? So, basically, let's look at this example to get a clear idea. So, basically, we're given this array, right? We're giving this array, and m represents number of bouquets. Here the number of bouquets is in the question it's 3, right? So the number of bouquets is 3 and the number of flowers is 1. So the number of bouquets is 3 and each bouquet must contain one flower. So let's say these three are the bouquets and each bouquet must contain one flower. So this must have one flower, and this must have one flower, and this also must have one flower. So if we look at the array, we have been given this array like 1, 10, 3, 10, 2. This means that this is day 1. This is not by 1. This is day 1. On day 1, the first flower will bloom, right? So since I only need one flower, I'll take this flower and I'll keep it in this one, right? Then these two will be empty. And on day 2, the last flower which will bloom on day 2 will bloom, and we'll take this and keep this inside our bouquet, right? And then on day 3 there is another flower which blooms on day 3, so we'll take this and we'll keep it inside our bouquet, right? So what is the maximum number of days that we are taking? We are taking 3 days, right? So the answer is 3. And if we continue the process on day 10, all the flowers will be bloomed, right? So I hope you got the basic understanding of the question. So let's look at this question. Here we need 3 bouquets with 2 flowers in each bouquet. We need 3 bouquets, 1, 2 and 3 bouquets, and each bouquet must contain 2 flowers. But if you observe carefully, there are like 1, 2, 3, 4, 5. There are only 5 flowers, but we need 3 bouquets into 2, right? 3 bouquets into 2, which is we at least need 6 flowers, but we only have 1 flower, and each flower can only be used to make 1 bouquet. They have already mentioned that in the question. Where is that? Yeah, and then can be used in exactly one bouquet. So each flower can only be used in exactly one bouquet. So since we have less flowers, the answer is -1. And if you look at this example, we need two bouquets. One, two. And each bouquet must contain three flowers, right? So here the another trickiest part is that we can only pick three adjacent flowers. We can either pick these three, or we can either pick these three, or we can either pick these three like adjacent. You understood, right? We cannot pick one flower from here, one flower from here, one flower from here. We can only pick we can pick all the three flowers at once like this. Just pick them and pluck them out of the ground. So if you look at this example, on day 1 nothing will bloom. So on day 2 nothing will bloom. On day 3 and day 4, day 5, day 6. When we come to day 7, all these 4 will bloom and all these 2 will also bloom, right? So using this I can make a bouquet, right? I'll take these 3 and make a bouquet. This flower is not bloomed, right? So I cannot make a bouquet like this, right? So I'll wait till day 12. When day 12 arrives, this flower will also bloom, and I can make a bouquet like this, or I can also make a bouquet like this, right? So I just need two bouquets. So I'll keep this one in this bouquet, and I'll keep this one in this bouquet. So what is the maximum date that we are going to in order to make all these bouquets? That is number 12, right? So this is basically the question. So now let's look how we can solve this by using the most brute force approach that we can. So when we come to approach 1, what we are going to do is that basically what I'll do is I'll start and iterate each and every sub. I'm sorry, wait. So now let's look at this example, guys. So in this example we have these days on which the flowers bloom, and we need three bouquets, and in each bouquet we need three flowers, right? So in the approach 1, what I'll do is I'll just apply the brute force approach that I can. What I'll do is I'll just take the first three flowers and I'll keep it in my first bouquet. So in order to make my first bouquet, I'll take the first three flowers. So I'll take the worst value. The first flower will. Before that, I'll ask you one question. So I have three flowers, which one blooms at 2, another blooms at 4, and the other blooms at 1. So in order to pluck all of these three, so on which day can I do that? Right? I cannot do that on day 1, right? Because these two flowers are not yet bloomed, right? So I cannot also do it on day 2. I cannot also do it on day 3. I can only do it on day 4, right? Because on day 4 all these flowers will be bloomed. Let's take another example, something like 3, 1 and 10. Suppose if we have this, on which day I pluck all of these out? On day 10, right? Because on day 10 only all these flowers will be bloomed. So using this idea, what I'm going to do is when what I'll do is I'll try to pluck the first three. So in those three flowers, on which day can I pluck these three, which is the maximum value, right? So I can pluck this on day 5, right? And I'm going to pluck these three. So on which day I can pluck? On day 4, right? And I'll pluck these three. On which day I can pluck? It is on day 3, right? So what is the maximum value out of these three values? 5, right? So the answer will be 5 in order to make this. This is because we need to tell them the minimum number of days you need to wait to be able to make n bouquets. So we can also pluck all of these flowers in 10 days. After 10 days, all of these can be plucked, but we need to tell the minimum value, which is 5. If we assume our answer as 4, on the day the this flower will not be bloomed, right? So we cannot make this. This is one of the this is one of the example. Let's take another example to get a better idea of this. Now let's look at this example, guys. Now I just need two bouquets. I just need two bouquets, and in each bouquet I need two, uh, two flowers, right? So what I'll do is initially I'll take these two, which is I need to wait till day 5, and then I'll take these two. I need to wait till day 4, right? So what is the maximum value of these two? 5, right? So if I take the first four flowers, then I need to wait till day 5. Now what I'll do is instead of taking the initial values, I'll take these two flowers for initially, and then I'll take these two flowers. We cannot take we cannot take these two again. This is because one flower can only be used for one bouquet. One flower cannot be used for multiple bouquets, right? So when I take these two flowers, I'll try to take these two. Then for this I need to wait for 5 days. For this I need to wait for 4 days. So the maximum value is again 5, right? 5. Now now what I'll do is I'll take these two, and then I'll take these two, which is I'll wait for 4 days. Here I'll wait for 1 day. The maximum value is 4, right? 4. And then I'll take these two values. I'm sorry. I'll take another curve. I'll take these two values and I'll take these two flowers. Here I need to wait just 1 day, and here I need to wait 2 days, which is the maximum. 2, right? And at the end I'll take these two, but I cannot take this value, right? Because I at least need two flowers, but I only have one, so I cannot do this. So what is the minimum of all of these values? 2, right? So with this one I can make I can make two bouquets with two flowers each within 2 days, which is I'll take these two and these two, right? In this way we're going to solve this in this approach. But if you observe carefully, what is the time complexity of this approach is that what is the time complexity? We're basically creating groups of groups of k for n times, right? No, we're basically traversing the array. Initially I'll start from here, and I'll keep on making these groups like this till the end. And then again I'll start from here, and I'll again make groups like this, 1 2 1 3. And I'll start from here, I'll again make groups like this, right? So we're basically doing n square, right? The time complexity is n square. But if you observe carefully here, if you observe the constraints, the n value can go up to 10 power 5. So your 10 power 5 into 10 power 5 will be 10 power 10, right? This will give you a time limit exceeded, uh, because you need to execute your program within 1 second. So if in 1 second only 10 power 8 instructions can be processed. Since your program is taking more than 1 second, it will throw you a time limit exceeded error. So let's try to optimize this approach, the second approach. So this approach is bit hard to think, but once you get it, it's really intuitive, and it's really a great approach to apply to another problems as well. So this mainly uses one basic idea. So I'll ask one question, and using that question we'll try to move into this approach. So if I have something like 2 3 8 and 10. So if I have these values in my array, means the flowers will bloom on these days. So if I ask you one question, suppose if I pluck all these flowers on day 12, if I pluck all these flowers on day 12, I can pluck all of these, right? Suppose if I want to make two bouquets with two flowers each. Suppose if I pluck on day 12, I can make these two into one bouquet and these two into another bouquet, right? So I can do this in on day 12. So if I ask you, can I do this on day 14? I can, right? I can again, since these are already bloomed in day 12 itself, I can easily make on day 14. If I ask you day 16, I can. If I ask you day 20, I can. If I ask day 25, I can, right? So basically, what I'm saying is, if you can do something on particular day, like if you can do the bouquets itself on particular day, you can you can definitely the bouquets in the you know o- on more number of days, right? You, if you can do if you can do a work in 10 days, you can easily do it on 11 days, 12 days, 13 days, 14 days, right? So that is the approach. Now I'll ask you, if I can do the work in 9 days, if I can make the bouquets in 9 days, I cannot, right? In 9 days these two and this will be bloomed, so I can make this one pair, but I cannot make this another pair, right? So I cannot do it in 9 days. So then I'll move to 10 and I'll ask whether I can do this in 10 days or not. I can, right? I'll make this one group and I'll make this another group, since I'm plugging it on day 10. This is nothing but, if you observe carefully, let's take another example to get a clear idea. So now let's look at this example, guys. So in this example, I'm just asking whether we can do this in eighth day. If I'm plucking it on 8th day, suppose I need two bouquets with two flowers each. So if I'm plucking it on 8th day all the flowers will be bloomed. So I'll just make these two one flower, one bouquet, I mean, and I'll make these two one bouquet, right? So I can do it. So I'll ask you whether I can do this in 8 by 2. So let's say half, because we need to return them the minimum value, right? Here we need to return the minimum value. So I know I can do it in worst days possible, right? So I'll try to minimize it. So I'm asking you, can we do it in 7 days? Can we do it in 7 days? I can. I'll make these two and I'll make these two, right? I'll ask you, and I'm asking you right now, can we do it in 6 days? We can, right? I'll make these two, I'll make these two, right? And can we make it in 5 days? Yes, we can. We again can. Can we make it in 4 days? I can make these two, and I cannot make it, right? So the minimum value is 5, right? So what if I have something like this? One, what if I have something that's something very similar? 5, 4, 10,000. I mean 1 lakh. So here we're basically starting from the worst value. We're taking the worst number and we're like keep on constantly decreasing one day, one day, one day, and checking whether we can make the bouquets or not, right? So let's take this same example and do the same thing. So my day is 1 lakh, right? Since this is the worst one, right? Because on this day I can make the bouquets, right? So on this day I can. So this can be my answer. So I'll try to reduce it since we're asked to return the minimum value. So I'll make it 99999. I can do it on 99999 as well. Then I'll make 99998. Then I'll make 99997. Then I'll make 99996. Then I'll make 99995. Then I'll make 99994. If we keep on doing this, it will go down till like here we need two bouquets with two flowers. It will go on till five, right? It will go on till five because in order to make these two, we need 5 days, right? So it will go until five. So this is not a optimal approach, right? Because we're just reducing each time by one, right? What if the maximum value something like 10 power 9, which has 9 zeros, 1 2 3 4 5 6 7 8 9 0 9, yeah, 9 zeros. If you have 9 zeros, it will take a hell lot of time to you know to reduce to the number of bouquets, right? So instead of doing this, what I'm going to do is I'll apply binary search. Now what I'll do is I'll take a minimum value which is low as 1, and I'll take my high as the highest value. Let's say this value 1 2 3 4 5. Now what I'll do is I'll take a mid value. 1 plus 1 lakh by 2 is somewhere like 50,000, right? So I'll check whether I can do, suppose if I'm plucking on 50,000 day, then can I make two bouquets with two flowers each? I can, right? If I'm plucking it on 50,000 day, these are all already blooming in day 5, day 4 itself, right? So I can do it. Now what I'll do is I'll reduce my height to 50,000. So basically I started in between 1 and 1 lakh, right? So I checked in it at 50,000. So if I can make the bouquets on 50,000 day, I can also make it on this day, this day, this day, this day, this day, until this day, right? So there's no point in considering these days, right? So then I'll go back and I'll check in between these two. Now I'll have my range between 1 and 50,000. Now I'll again find the mid. It will be something near to 25,000, right? So if I'm plugging at 25,000, can I make? I can, right? So there's no point in checking these values, right? Because if I can make the bouquets on 25th thousand day itself, I can make it on 25,000 on first day, 25,000 on second day, 25,000 on third day, right? So since we need to find the minimum day, I'll again move back. Our range will become 1, 25,000, right? Now I'll check it on 12,500. I can make again, and again I'll reduce. It will be like 1 and 12,500, and here it will be like 6,200, I think. Again, it will keep on decreasing. It will become 3,200 because it is in between 1 and 6,400, and again it will become 1,600. This is 3,200, and again it will become 1 and 800. Here it is 1,600. This is nothing but mid value, and this is nothing but low value, and this is high value. And this will again become 400. This is the high value will be 800, and the middle value. If you observe carefully, we're basically ignoring half of the range, right? At every step, we're ignoring the half of the range, right? So in this way, at some point we'll go to, let's say, if you go to 3, if you go to 3 at 3, can you do it? You cannot, right? So at 3 you have the minimum value is as 1 and your maximum value as 5. Since you cannot do it on day 3, now instead of decreasing, because if you cannot do a bouquet in day 3 itself, you cannot make it in day 2, and you cannot also make it in day 1, right? So you'll move forward. So you'll try to find the in between value between 3 and 5, which is 4. So can you do it on 4? You cannot, right? Because you need to wait till 5. So so your range is between 4 and 5. Now now what you'll do is you'll find the middle value between 4 and 5, which is 4 plus 5 by 2, which is again 4. Now wait, so now you'll move to the right value. I'm sorry. Your range will become 5 and 5, which will be 5 plus 5 by 2, which is again 5. So you'll check whether you can do this, do the bouquets in fifth day or not. When you check, you can do the bouquets in fifth day, right? So in this way, we're basically doing login operations, right? In order to find the day, particular day. And at every step we are checking whether we can do the bouquets or not, right? So so it will take the time complexity will be we're taking log in time to decrease the to find the particular day, right? And at every day what we're doing is we're traversing the entire array to find whether we can do the bouquets or not. So the time complexity will be order of n log n, and the space complexity will be order of 1, since we are not using any extra space. So now let's look at the code. So here we don't need this. So as I said, I'll apply binary search on Bloom day, and min value and max value will I tried this but it didn't work. So I'm taking the minimum day as 1 and the maximum day as 29, because they have given in the question constraint that the maximum day that the flower can bloom is 10 power 9. So I just took it. 1 in 9 is nothing but 10 power 9. So initially my result will be minus 1. Now as I said, I'll find the middle value, and I'll say my middle value is nothing but the current day, right? And I'll go through the array, and I'll check whether I can make the bouquets or not. What Here what I'm doing is, this is the current day I'm in. Suppose if you look at this, if you look at this, the middle value is 50,000. Let's say the minimum value here, the minimum value is 1, the minimum value is 1 and the maximum value is 1 lakh, right? Now the mid will become 50,000, right? So the current day will be 50,000. So I'm at 50,000 day. I'll check I'll go through the entire array and I'll check whether I can make bouquets or not on 50,000 day. So initially my bouquets will be 0 and my flowers will be 0. Now what I'm going to do is I'll just count these three, and 3 in the sense I'll count the number of flowers that I want to make a bouquet. Since I need three flowers to make a bouquet, I'll count 3, and if I can make a bouquet on that particular day, I'll increase my bouquets and I'll make my number of flowers as 0. Suppose if I come here, if I say I can make a bouquet right here, so I'll again make my flowers as 0. Now I'll again try to make a bouquet with the next 3 flowers, and I am again able to make a bouquet, right? Since I'm in 50,000, I'm at 50,000 day. So on this day, all these flowers will be bloomed. So I got two bouquets, right? If if you see here, if the bouquets that I can make is greater than the bouquets that they have asked, then that means that I can make bouquets on this day, and I'm reducing my current day, right? So what I'm basically doing is, if I can make bouquets on this day, this can be the answer. I'll store this value in my answer, and I'll go and check on the left side, right? So basically what I'm doing is, suppose if I have 1 and 10,000, what I'm doing is I'm checking at 5,000. And if I'm able to do the bouquets on 5000, that means 5000 can be the answer. So I'll store 5000 in my result. I'll store the current day in my result. And what I'm doing is I'll I'm removing this range, and I'm only searching here because I need to minimize my answer, right? So I'm storing this as my worst answer, and I'm going to search on the left side. This is what I'm doing. So if I can make the bouquets, I'm storing that inside my result value, and I'm reducing my max as the current day minus one. So my max will come here, right? It is a typical binary search question. And if I'm not able to make the bouquets, that means, suppose if I have 1 and 10,000, if I'm not able to make the bouquets on the middle day, if I'm not able to make on this day, so I need to wait a bit more, right? So that is why I'm transferring my minimum value to the mid plus 1. So my minimum value will come here, right? Minimum equals to current day plus 1. So that's it, guys. That's what I'm doing in this code. And if I run this, it will gonna run fine. Yeah, that's it, guys, for this video. And we have already talked about the time complexity as well. It will take n log n to solve this question, and the space complexity is order of 1. Thank you, guys. If you have watched till now, you have a lot of patience than me. So thank you so much for watching, and yeah, that's it, guys. Thank you.